Good morning, good afternoon, whatever you say. It's 12 noon. So we start our so good afternoon. This is around 12 noon now. So we start our lecture 6.2. So this is lecture 6.2. This is on wheel loading. Today we will be giving some analytical treatment to wheel loading so that it is possible for you to predict which particular combination of wheel and process parameter is more prone to wheel loading. Yesterday I have received two emails, one from Ashok, another one I cannot recall the name. Both of you have shared the same material with me. This is regarding the evaluation procedure. Maybe by this weekend I will propose something and I will send it to everyone by email. I hope it would be acceptable. So what is wheel loading already we have discussed. Yesterday I could not give you a pictorial depiction of this. This is the pictorial depiction of a wheel loading. This is the width of the wheel. So this is basically BS and this is the circumferential direction. And as you can see, you have grids over here and once again you have grids over here. Along the line, grids are not very regular, but at least there is some amount of uniform distribution attempted. Despite that, as you can see here, you have a rather large patch of chip material which are loaded. Here also there is a large patch of chip material which is loaded. So this is the depiction, actual pictorial depiction of loaded chip particle. Okay. You can also search a particular guy's, his name is Rubenstein. He has two papers. You can search with the author as Rubenstein and the keyword as wheel loading. You are going to get two papers, so you can go through them as well. Whatever has been covered more or less has been discussed in those papers, but whatever I am going to cover today, they are not there. That particular treatment is not there in any of the papers. So that's what we are going to start. I do not know what is happening with Anup Kumar Singh. I am trying to admit him, but he is not getting admitted. So let us go to the next slide. So yesterday itself we have indicated that because of some constraints, you have wheel loading. And what are those constraints? Those constraints are listed here. They are space constraint, and out of those space constraints there are two length constraint. One is thickness, another one is length constraint, another one is volume constraint. What do you mean by thickness? A chip would have to be accommodated here. To accommodate the chip here, the thickness of the chip has to be less than the protrusion of the grid. This is the average grid diameter. As far as protrusion is concerned, protrusion is much less than that. This is the bond post and this is the bond level. So protrusion is only this much. So this RP, if it is less than A2, then your chance of wheel loading will go up. Now how A2 is related to something else? Already we have seen there is something called HM. HM is uncut chip thickness, or rather it is maximum uncut chip thickness. There is another name for it, maximum grid depth of cut, but that name is not very useful today. So it is basically maximum uncut chip thickness. From machining we know A2 by A1 is zeta, which is chip reduction coefficient, and thus A2 would be equal to zeta into A1. In this particular case it would be zeta into HM. Already we have calculated HM. HM is typically a few micron. Then how much is A2 going to be? Now zeta can be estimated roughly by this equation, and gamma effective is minus 60 degree. And I believe you people have calculated zeta earlier in case of grinding, and it used to be around 10 to 15. So if HM is 3 micron, then your A2 could be very well 40 micron or so. So the protrusion, if it is less than that, then you have a problem. Typically for vitrified alumina chip, your protrusion is around 30% of DG. So if your DG is 150 micron, so RP would be also around 45-50 micron. So this particular quantity and this particular quantity, they are very similar. So if you have 10 cases, and out of which wherever your RP is less than A2, there the chance of wheel loading would be more. Where it is more than A2, the chance of wheel loading would be less. So this is the first constraint, which is called the thickness constraint. Okay, ultimately Anup Kumar Singh has entered somehow. Okay, the next one that we are going to talk about is length constraint. What is length constraint? This was discussed in the last class. This is the pitch. This is the center of the grid. This is the center of the grid. This is the pitch between the grid. Yesterday by mistake I have designated it by small lg. Please correct, if you have taken note, please correct that. Put it as capital LG, because small lg we have already used for geometric contact length. So to avoid confusion, this has to be used. Now this LG, if it is less than length of chip, in that particular case your wheel loading chance would be higher. Now let us take a simple case of, oh God. Let us take a simple case of shaping operation to find out this particular relation. So this is a long block and that you are shaping. You are shaping with an uncut chip thickness of A1 and its width is capital B. Thus, material removed due to shaping would be A1 into B times this length L. What is the chip? The chip looks like this, where this one is A2, this is B, and the length of the chip is L chip. So that material volume would not be different. That would be A2 into B into L chip. So we can equate them. A1 into B into L equal to A2 into B into L chip. So these two will cancel out. Your A2 by A1, which is zeta, would be equal to L divided by L chip. Now, in our grinding situation, what is my L chip? It is same. What is this capital L? This capital L, if you can understand now, is nothing but the contact length, which is A upon ds. So, zeta, this I am using ds, but in practice it is dE, but I will do all treatment with respect to surface grinding. So, zeta becomes your LC divided by L chip, and in that case, L chip can be calculated as LC divided by zeta, which is root over ADS by zeta. Now already you have calculated LC quite often. This is a few millimeter. So if LC is 5 millimeter and zeta was 10, then your L chip value would be somewhere around 0.5 millimeter. So if this 0.5 millimeter is more than LG, then you have a high chance of wheel loading. One of you please call Anup Kumar Singh and ask him to use go to a place where he has better network connection. Anup Kumar Singh, if you have entered the room, please go to a place where you have better network connection, because your network is dropping quite frequently and I have to admit you multiple number of times. So please proceed to a place, part of your house where network connection is better. I hope you could hear me. Can you hear me, Anup Kumar Singh? Where is he? Anup Kumar Singh, can you hear me? Anup, please go to a particular part of your house where you have better network connection and please mute yourself. So that addresses two of them. What are those two that we have addressed? We have addressed thickness constraint. We have also addressed length constraint. Next one that we are going to discuss is volume constraint. What is the volume? This is a two-dimensional view. So the volume cannot be seen, but you can imagine this is the intergrid volume. that we will designate as, if this intergrid volume is less than the chip volume, then your chance of wheel loading would be more. As far as chip volume is concerned, it is equal to the volume of the chip groove that we have estimated earlier. The chip groove typically looks like this. Assuming that the grids are square pyramidal in shape, and further assumption is that their apex angle is 120 degree, and this chip volume is 1/3 hm square tan alpha into LC. If any one of you have taken class note from the video, please check whether I have written it correctly or not, because I do not, I derive them on the go, I do not remember them, so I might have made a mistake, maybe. So this is the chip volume that I can recall. If this chip volume is more than the intergrid volume, as we have written earlier, then your wheel loading chance would be more. So what is the task left? Task that is left for us is estimation of this intergrid volume. In the next slide, that's what we are going to do. Now, this is the 2D depiction that we have done earlier. These were inverted, so center of the wheel was in this direction. Now I have inverted them, so the center of the grid wheel is in this direction. And if this is the diameter of the wheel, this is 200 millimeter. It is not a very bad number. Whereas this is the protrusion. Protrusion RP is typically 30% of DG. So if your DG is 100, this is hardly 30 micron. So for all practical purposes, this curved line can be taken as a straight line. How much is this distance? This distance we have already calculated. This is the pitch. This is LG. So LG into this RP will give me an area. The other dimension what I require is coming in this particular thing. So this is 3D depiction. It is the same depiction. This is the grid that I have drawn, but instead of an actual grid, what I have drawn is a square pyramidal. The other side of the pyramid I have not drawn. So here you have a plane which is the mid plane of the pyramid. And here you have the mid plane of the pyramid. For the time being, whatever is shown in the green, forget it. Our first task is to find out the first volume, that is gamma 1. What is gamma 1? Gamma 1 is the volume between two mid planes of the abrasive. After that, what would you do? We would find out gamma 2. What is gamma 2? Gamma 2 is volume of half of the abrasive. When I write this abrasive, there is a inherent thing that I am not mentioning. This abrasive is nothing but protruded part of the abrasive, nothing else. Not the full abrasive, it is the protruded part of the abrasive. If you are taking a running note, please replace that as protruded part. So this protruded thing should appear here as an adjective. It should appear here as an adjective. So this gamma 1 and gamma 2, if we can calculate separately, we would have gamma intergrid as gamma 1 minus gamma 2 into 2. This gamma 2 into 2. Why? Because in this side you have this volume between the red lines and the green lines. This is half of the protruded part of the pyramid. On this side also you have half. So that is gamma 2 into 2. That's what we are going to do. So first thing first, gamma 1. So for calculation of gamma 1, let us call this as A, let us call this as B, let us call this as C. This is X, this is Y, this is Z, maybe this one is D, and after that I will drop a perpendicular which is E. So what is gamma 1? Gamma 1 is LG, this distance, into area of triangle ABC. Let us draw triangle ABC separately. This is A, this is C, this is B, this is the dropped perpendicular E, this is 2 alpha. So how much is this area? This area is half AB into C, which is equal to AE into C, which is equal to, I will write what it is. Now let us take tan alpha. Tan is perpendicular by base, so if this is angle alpha, perpendicular is AE divided by CE. So AE becomes CE times tan alpha. What is CE? CE is nothing but protruded part of the grid, so it is RP. So this becomes RP square tan alpha. This I am keeping as LG, and I am reminding you that LG is nothing but 1 upon C. This was discussed in the previous class. I am not discussing it once again. So one part of our task is done. This is equal to RP square tan alpha into LG. If you do a dimensional analysis, this is millimeter square, this is millimeter, so this is millimeter cube. It is matching as far as our derivation is concerned. Now let us go to the second one, that is the volume of a pyramid. For volume of a pyramid,
Sir,
yes,
sir, divide by 2 in this volume 1.
divided by 2, half of CAB equal to AE. So AE is RP tan alpha, so it is RP square tan alpha. So this divided by 2 is taken care of by this expression. Who was it? Gajanan. So is it clear to you now?
Yes, sir.
Okay,
Yes.
thank you so much. It is, do not feel shy to interrupt me. There is no issue. Your interruption could be correct, your interruption could be wrong. The dual degree student know very well that I quite often make algebraic mistake while deriving formula. I quite often make arithmetic mistake while solving numerical problems. So be very cautious about it. People say that I make them intentionally to check whether the students are sleeping or not, but that is another story. I will not spend my time telling that story with you. Okay. So one such mistake that I might have committed is gamma chip. So please, if you have taken note, please find out whether this particular expression is correct or not. Now let us go for gamma 2. So what was gamma 2? Gamma 2 was half of protruded, half of volume of protruded part of abrasive. So how does it look like? This was called A, this was called B, this was called C, this was called D, this was E. Now I am looking at the base from the top, all these angles are 90°. This one is B, this one is A, this one is D, this is 90°. And here you have E, and your C would be superimposed on this. Already we have calculated AE. AE is RP tan alpha. So AB is 2 RP tan alpha. What is AD? AD is AB into cos 45°. So AD is equal to 2 RP tan alpha by 1 upon root 2. So it is root 2 RP tan alpha. How do you find out this gamma 2? Gamma 2 is area of the base into 1/3 height. So how much is the area of the base? Area of the base is half into AD square into 1/3 height. What is your AD? AD is this. So AD square is 2 RP square tan square alpha. So this becomes half into 2 RP square tan square alpha into 1/3. And what is the height? Height is nothing but C is equal to RP. There I have not introduced one particular term. That term is this one. When I have written this expression, I did not make this mistake intentionally, but this is basically to be multiplied by 2. So this has to be multiplied by 2, and ultimately if you multiply it by 2, gamma 2 becomes 2 by 3 RP square tan square alpha, RP cube tan square alpha. So this is the negative part. So our gamma becomes gamma 1 minus gamma 2. Gamma 1 where we have derived RP square tan alpha Lg. So this is RP square tan alpha Lg, and this one is 2/3 RP cube tan square alpha. I hope I have written it fine. So this is gamma. This gamma is nothing but intergrid. So if this intergrid space is less than the chip volume, then your wheel loading chance will go up. So when a process parameter is placed in front of you, then what do? You have to check 3 criteria. What are those 3 criteria? One is RP, is it less than A2? Number 2 criteria, LG, is it less than this? Number 3, is it less than this? So once you check these 3 criteria, then you can opine whether wheel loading will take place or not. Okay, so this is the way we have to analyze the problem. I haven't set up any problem today, but we have enough time, so we can try to set up a problem and see what happens. So for doing that, let us go to a new slide and I will set up a problem. So this particular problem is for flange surface grinding. BS is 35 millimeter. I do not know whether it would be useful. BW is 10 millimeter. A is 45 micron. DS is 200 millimeter. DG is 150 micron. C is 40% of Cmax. And you have two cases. One case, your Vs is 50 meter per second and VW is 100 millimeter per second. In another case, Vs is 100 meter per second and VW is 150 millimeter per second. So in which case you would have more probability of wheel loading, that you have to analyze. RP is 30% of DG. And for analyzing this problem, you need to analyze from volume constant point of view. Other constant you need not have to worry about. How do you approach this problem? So, if you are not thinking, then what may happen, I will tell you. Let us write down the expression of gamma intergrid that we have derived just now, which is, can I, Rp square tan alpha Lg, okay? Rp square tan alpha Lg minus Rp cube tan square alpha, possibly there is a multiplier of 2/3. This is it. In this particular case, what you will do, you will initially find out what you have been asked to analyze. That is very important. You have been asked to analyze out of these two cases, which one is more prone to wheel loading. No one is saying whether wheel loading will take place or not. You are simply asked to find out which one is more to wheel loading. So one approach could be, you will find out intergrid space, you will find out gamma chip 1, you will find out gamma chip 2, and you will compare the calculated value of intergrid chip with these two. Wherever they are more matching, or that means wherever this particular relation gets satisfied to a more extent, you will say that is more wheel loading prone. If you solve this particular problem using this approach, would you make a mistake? Absolutely not. You will not make a mistake. You will get the correct solution, but it will take huge amount of time. So what do you do? How can you solve this? Once again, let us look at this expression of intergrid, and for that I require space. So please wait. So intergrid In this equation, tan alpha is not changing. Is Rp changing? From case 1 to case 2, dg value is not changing. dg value is same. So even Rp is not changing. What about Lg? Lg is also not changing. C is outside. So it is not changing. So this expression of integrate is same whether it is case 1 or whether it is case 2. So there is no need to calculate it at all. What you do is that you calculate this and you calculate this. Whichever is more out of them, that is more wheel loading prone, because you have not been asked to provide a absolute answer. So let us do that. To do that, so Lg was root over ADS, which was 0.045 into 200, which is hopefully 9. So Lg is equal to 3 millimeter. That we have calculated. Now we have to calculate HM. To calculate HM, we have 3 by C tan alpha VW by Vs root over ADS. Now even in this particular term, there is one interesting thing. This is not changing, this is not changing, this is not changing, this is not changing. So nothing is changing. Only thing which is changing is these two quantity. So why should I calculate gamma chip? I should not even calculate gamma chip. Then how do you solve the problem? You solve the problem in this fashion. Lg would not change because A and D is not changing. So these two will cancel out. These two will cancel out. These two will cancel out. So you will be ending up with Hm square by Hm2 square, which is 3 by C tan alpha Vw1 by Vs1 divided by root over ADS. On the denominator, you would have 3 by C tan alpha VW2 by Vs2 divided by root ADS. So everything cancels out. So you are left with VW1 by Vs1 divided by VW2 by Vs2. If I recall, this was 0. Was 100 millimeter per second. So 0.1 millimeter per minute, and this was 50. And the second one was 0.15 and this was 100. So what happens? 0.1 by 50 into 100 by 0.15. So 2 into 10 by 15. So it is 20 by 15. So it is 4 by 3. So this becomes 1.33. So this ratio is 1.33. So gamma chip 1 is definitely more than gamma chip 2. In both the cases, this intergrid space is same, and because of this reason, this particular case 1 is more prone to wheel loading amongst these two. Would it provide wheel loading? That we cannot decipher. That question has not been asked. All you have been asked is which case is more wheel loading prone. If you were asked to analyze the whole problem, it would have taken a lot of time. I am not doing it in a pen and paper, I am doing it in a computer, so I am rather slow. But in a computer also I have taken 15 minutes of time. You people will take more time, and if you have to analyze the whole problem from length perspective, from thickness perspective, from volume perspective, giving it a full treatment, you will require much more time. Okay, now this particular problem, you take it as an assignment which is not to be submitted. Not to be submitted, you do it on your own. For doing it on your own, you have to find out zeta. Zeta is equal to e to the power mu pi by 2 by gamma effective. I believe we have used this equation earlier and we did take a zeta value of 0.8 or so. So there was a call drop from my side. I hope all of you can hear me now.
Yes, sir.
Okay, thank you so much. There was a call drop from my side, so that is rather strange, but still it has happened. Okay, now let us go here. So as I was saying, you can analyze it for all of them. That means for thickness, where is it? For thickness constraint, for length constraint, as well as for volume constraint, not relative evaluation but actual evaluation, that you can do as an exercise. This will sharpen your skill. And for thickness and length, you would require zeta to be available. Just a minute. Am I still there or have I been? Just a minute.
Yes, sir. You are there, but screen is not seen, sir.
Oh, screen is not shared. Now I hope the screen is visible.
Yes, sir.
So what I was telling is that you can analyze the full problem, not for just for the sake of which one is more wheel loading prone, but actual comparison. And for doing that, you can take thickness constraint, you can take length constraint, and you can also take volume constraint. And for doing that, you would require the value of zeta. For calculation of zeta, you can find out the value of mu. I just will go back and find out whether you would require anything else. This is cheap, so for finding out zeta is required. Here thickness, so HM calculation, all other things are given. I hope all other data are given, so please do it. This is an assignment which should not be evaluated, and it need not have to be submitted, but you do it on your own, and maybe once I go through those two emails and decide something, then this can be posed as an assignment and I'll ask you to submit. But at this moment, this you need not have to submit. But if you undertake this assignment, it will definitely help you in clarifying your ideas, whatever you have learnt in the class. So that's all for today. So that completes our 6th module as well. From the next week onward, we will be starting something else. The dual degree students, in the last class, indicated to me not to have a quiz on Saturday. So this Saturday we would not have quiz. Possibly we would be having it on Wednesday. Sorry, Friday. Someone is trying to come in. I'll allow you to come in. Please give me some time. Okay, just a minute. Yes, someone was coming in. Please come in. Please tell me what is your name and tell me.
We have, sir, I am Ashok Moore.
Yes.
Sir, sorry for my mistake, but actually we have Viva from next week. So you can take a quiz in this week.
You have Viva from next week. Okay. So this Saturday I can take the quiz. Okay. Then we are scheduling the quiz on 17th. On 17th there would be two quizzes. 17th the class starts from 9 to 9:30. It is 9 to 10:30. So possibly it will start from 9:15 to 9:45, and there would be another quiz from 10 to 10:30. So there would be two short quizzes. Even they may not be for half an hour, they would be for less time, and they would be primarily based on whatever you have learned in fourth module, fifth module, as well as sixth module. So what is fourth, fifth and sixth I cannot remember. Sixth is definitely wheel loading. The fifth was wheel conditioning, and possibly fourth was chip formation. So these two quizzes would be from these three modules. Okay. So let me take the attendance now. Vinit Malik. I have seen this guy in the morning. What is happening? Shiva Shankar.
So he is there.
He is there, but whenever he is responding, I hear a bird chirping, but not his voice. I don't know why. Kailash.
Yes, sir.
Okay, thank you. Bipul Kumar.
Yes, sir.
Okay, Harsh.
Yes, sir, present.
Arpit.
Sir, present.
Shantanu.
Present, sir.
Ashok.
Present, sir.
Ankit Anurag.
Present, sir.
Anup Kumar Singh. Anup Kumar Singh was coming in, going out, something wrong with his network connection. I will mark him present. Muralidhar.
Present, sir.
Ritesh.
Sir, present. Sir, present.
Girish.
Present, sir.
Gajanand. Durganand.
Present, sir.
Rohitas. Fine. Sharjil.
Present, sir.
Thank you so much. So, as dual degree students do not have any problem in having having quiz in this particular Saturday, and MTech students as such, you do not have any CDC, that is your placement related issues. So we will have this on this Friday. On this particular Saturday, the formal notice would be sent. Shiva Shankar, are you trying to talk to me? I cannot hear you. I have given you attendance. If you can see here, I have given you attendance.
Actually, you are not presenting the screen, sir. That is why he got the doubt.
That was my mistake. That was definitely my mistake. Now you can see the screen.
Yes, sir.
Yeah. So Shiva Shankar, can you come back and see, check whether you have been marked present or not? Are you happy with it? Please raise your hand. What is happening with your voice? I cannot hear you. Okay, forget it. Okay, thank you so much. I'll end the meeting here, end the class here. Thank you.